All right, all right, all right. Today we're talking about some chain rule stuff. So with every chain rule, we're going to have the composition of two functions, right? So we have a function inside of a function. So the derivative, if we have this as your function, or if we have something called that has an equation or a function wrapped inside of a function, we always take the derivative of the outside function first and leave the inside one alone, and then we multiply it by the derivative of whatever that inside function is. Okay, so what we're going to do on this video is we're going to identify what our outer function is that we take the derivative of first, and then we're going to identify what the inner function is. In this case, our inner function is g. Okay? So we're going to hopefully become familiar with what functions, what equations need a chain rule derivative and what functions do not. Okay, so I'm going to make up some random ones here for us to look at. So here is a nice polynomial looking function, and if you want it to be so ridiculous, you could multiply this by itself 7 times and get a long, long polynomial. Okay, perfectly normal way to do that. No, completely abnormal. So let's do two things. Identify what is the outer function in our problem. And that would be raising something to the 7th power. Right? So we see these parentheses here and the power of 7. Okay, so the 7th is on the outside basically of our function, so that's our outer function, and our inner function is everything inside of the parentheses. Okay, so we have our outer function and we have our inner function. So the first thing we're going to take the derivative of is the outer function. Okay, so we're going to use our power rule, right, which says we bring our power to the front as a multiplication problem, times whatever it is that we have, and we raise it to the 1 less power. So this is to the 6th power. Okay, so we don't touch the inner stuff yet at all. So this stays by itself. It does not change. All we've done is taken the derivative of our 7th power. And now that we've done that correctly, we're going to come back and do the derivative of our inner. The derivative of 3x to the 4th plus 2x is 12x to the 3rd plus 2. Okay? And that is good enough. We don't have to simplify that any more than it already is. Okay? We have done the calculus. That is our derivative according to the chain rule. So first we take the derivative of our 7th power, and then we take the derivative of our inside function, which is that 4th degree. Excellent job. Let's look at another. So here is our next one. This happens to be a square root function. So our outer is going to be the square root function. So we're going to take the derivative of a square root, which hopefully you have memorized that one, and we don't have to go over that. And the inner function is all the stuff underneath your radical. So x to the 5th plus 3x squared. So we first start by writing our derivative. So f prime equals, we're going to take the derivative of our square root. So hopefully you have this one memorized. That is 1 over 2 times the square root of whatever we have underneath your radical. Okay, so just memorize that derivative. The derivative of a square root is 1 over 2 times its square root. So we're not messing with the x to the 5th plus 3x squared just yet. All we've done is taken the derivative of our square root function. And now to apply the chain rule, we multiply that by the derivative of this stuff underneath your function, which is plus 6x. Okay, 5x to the 4th plus 6x is a derivative of x to the 5th plus 3x squared. Okay, now when we simplify this, what's going to happen is our 5x to the 4th plus 6x is basically going to become our numerator of our function here. So this is how we would simplify this type of a derivative, is by simply putting the x to the 5x to the 4th plus 6x in your numerator and leaving everything else alone. Sorry, that's not a 2, that's a 5 plus 3x squared. Okay? And that's going to be your derivative. So the derivative of your radical will always be in your numerator. Now, if this happened to have been something that's divisible by 2, we could have divided both of those terms by 2 to reduce. But because 5 is not divisible by 2 nicely, we're going to leave it alone just like that. Excellent. Okay, let's do some more. So let's look at a trig one, the sine of 3x squared. Okay, so our outer function is the sine, right, the trig thing, and the inner function is your 3x squared. Okay, so when we take this derivative, we're first going to take the derivative of sine, which is, what is the derivative of sine? That's cosine. And we're going to leave our 3x squared alone because we haven't taken its derivative yet. We just did the derivative of sine. And then since we've done that one, now we can multiply by the derivative of your argument, which is 6x. Okay? So cosine of 3x squared times 6x, which is a perfectly good way to write it. But if you're going to see this on a multiple choice test, usually they would bring the 6x algebraic function in front of the trig function. Okay, that's just math acceptableness. That's how you're going to see it. Okay, but the green one and yellow and white one, they're in the middle, that is also 100% correct. So here we have another trig one. And trig is always going to be, well, no, it's not going to always be, but in this case, the secant is your outer function, and the inner function is what we have in parentheses. So the parentheses will always be your inner function, or the thing underneath your radical will always be your inner function, or the thing in the power will always be your inner function. So what do we remember about the derivative of secant? This is the secant of our argument times the tan of our argument. Okay? So these trig ones, you just need to memorize. That's the best way to do it. Rather than deriving them every single time, just memorize. The derivative of secant is secant tangent. Okay? And our argument is 5x plus 3. So this all goes with the secant. Right? This derivative, this whole entire thing, is the derivative of just secant. And now, what is the derivative of 5x plus 3? Right, it is just multiply by 5. Okay, so this is what our derivative looks like. The only thing we could do, I guess, if we wanted to simplify, is move the 5 to the front. That would be the only thing, because this is traditionally the way that mathematics people write their problems, as they put the numbers and the variables, all of your algebra stuff before you put your trig stuff. So 5 secant of 5x plus 3 times, right, this is all times the tangent of 5x plus 3. Very, very good job. All right, let's look at some more. Okay, this one is an base of e exponential. Okay, so these have a special factorization. The derivative of a base of e exponential is the exact equation that you see. Okay, so our outer is e to the whatever, right? Our base here, e to the x, is our outer function, and your inner function is actually your exponent for an exponential. Okay, so the outer function is your e, and the inner function is your power for an exponential. Okay, So y prime equals, the derivative of an e value is the exact equation that we're given, right? So this is its own derivative. Always, every single day, even tomorrow, the derivative of an e function is itself times the derivative of its power. So the derivative of 3x is 3. Okay? And like we normally do, we write the number in front of the power, okay, in front of the equation. So this is multiplication. Remember, anytime we do a chain rule, it's always multiplication. We never have any pluses or minuses in between our terms. So here we have another exponential. So anytime we have an exponential, your outer function is the exponential function. E to the power of whatever the power is. And the inner function is your exponent. So this case, our exponent is 2x squared. Okay, so let's take the derivative. The derivative of an e function is itself. So e to the 2x squared. It is its own derivative times the derivative of our power. So what's the derivative of 2x squared? 4x. So we write 4x first, and then e to the 2x squared is your final answer. Our next little function here is the sum of two functions, and they're both e's. So we're going to take the derivative using the chain rule for the first e, and we're going to take the chain rule, or the second e also, okay, separately. We're not going to do them at one time. Okay, so we're going to apply the outer and the inner for this function. So y prime, which is the derivative of e to the x cubed, is itself, so e to the x cubed times the derivative of x cubed, which is 3x squared. Okay, plus 5 is going to hang out there while we take the derivative of e to the 2x, which is, well, itself times the derivative of 2x, which is 2. Okay? So when we're taking the derivative of an e, just leave the number, right? There's a number multiplied by it. Leave the number alone and take the derivative of your function. So now a little bit of simplifying and rearranging. We're going to put the 3x squared in front of e to the x cubed. And 5 times 2 is 10, e to the 2x. And that would be your final answer. There are no like terms that we could combine or anything. All right, here we have a natural log function. The natural log of a linear. So the outer function is your natural log function. And the inner is your 4x minus 1, or your linear function. Okay? It's in parentheses, right? It's inside of the natural log. So hopefully you memorize the derivative for natural log. Okay? So a natural log derivative is 1 over whatever the argument is. 1 over 4x minus 1. Whatever is in parentheses after your natural log, that goes into your denominator. That's how we do the derivative of a natural log. And then we multiply it by the derivative of your argument, which is just, in this case, 4. Right? The derivative of 4x minus 1 is 4. Okay, so we can do one step of simplification, and that is to move the 4 to your numerator. And since we have a subtraction on the bottom, nothing can cancel. Right, so that is as simple as our function can be. 4 over 4x minus 1. So the derivative of natural log is 1 over x, whatever is in the argument. Basically, it's going to be x prime, right? The derivative of your argument divided by the argument itself. Okay? That's our shortcut for doing the derivative of a natural log. Right? So the derivative of whatever we have in parentheses, whatever we're taking the natural log of, that guy's derivative goes in the numerator, and the normal, right, the untouched function goes in your denominator. Here we have another natural log practice. So the outer function is your natural log, and the inner function in this case is your quadratic x squared plus 3x minus 2. Okay, so we're going to use that shortcut that we just developed a second ago and take the derivative of your parentheses and then divide it by your parentheses. Okay, so what's the derivative of x squared plus 3x minus 2? 2x plus 3 is that derivative. Okay, so the derivative of your argument goes on top, and then the argument itself goes on the denominator. Okay, and that's our shortcut, right? That's our natural log hack. Take the derivative of your parentheses on top, and then put your entire parentheses on the bottom. Okay, look at this one. Here we have the natural log of the square root of 3 times some number. Okay, so natural log square root of 3 times some number. So in this case, how many functions do you see? 3 functions. Okay, we have 3 functions in this case. So our outermost function is the natural log function. Okay, and then our next one, our middle, is the square root function. And then finally, our innermost function is 3x, the linear. So we're going to take the derivative of your natural log, and then we're going to take the derivative of your square root, and then we're going to take the derivative of 3x. Okay, so we're going to have 3 chains to follow for this problem, because there are 3 functions. So first of all, we do 1 over the natural, 1 over whatever's in parentheses, right? So this is 1 over the square root of 3x. Okay, so that's first. That's the derivative of our natural log. Times, what's the derivative of our square root? That's 1 over 2 times the square root of whatever is underneath your radical there. Okay? So this is our square root of 3x derivative. This stuff right here is right there. And then our last one, what's the derivative of 3x? Right? That's just 3. Okay? So let's talk about our algebraic simplification now. So what goes into your numerator is the 3, right? Because this is 3 over 1. Your numerator goes up top, and your denominator goes underneath. So 3 over 1 means the 3 goes up there. Okay? Now, let's do this. What do I get when I multiply root 3x times root 3x? I get a normal 3x. Anytime I multiply a radical by itself, I get whatever is underneath my radical. Okay? And I still have a 2 to multiply by. Okay? So looking at this, I basically have 3 over 6x. So what can I simplify? The 3 can divide by the 3. So my final answer will be 1 over 2x. Right? So this one happened to have some simplification that can be done. Okay, so once we're done with the calculus, go back and see if you can simplify through your algebra. Okay, so we're running out of time here in class. So to sum up, right, anytime we have a natural log or an exponential or a square root or a trig, chances are you're going to be using a chain rule in order to take its derivative. So the outer function first times the derivative of the inner function. Great job. Have a swell day.